So कल हम क्या कर रहे थे? कल हम देख रहे थे कि डायोड को स्मॉल सिग्नल के लिए हम लोग क्या करते हैं, रेजिस्टेंस से रिप्लेस करते हैं. So and we have seen the dynamic resistance, जिसको हम AC रेजिस्टेंस भी बोलते हैं, डायनामिक रेजिस्टेंस और AC रेजिस्टेंस of diode is given by RD, and that is your eta VT upon ID. Now let me solve one problem which came in exam. So we have a 12.7 battery and we have a AC source, okay, whose VI is given VP sine omega t, sine omega t, and the VP value is 100 millivolt, okay, and here they are given one resistance of 9900 ohm, and they have connected 4 diodes in series, and these all 4 diodes are made of silicon, okay. So जैसे silicon बोला है, that is these are 0.7, 0.7, 0.7 and 0.7, okay. Now what they are asking in the question, find the DC current ID, find DC current ID, number one question they asked, and number two they asked amplitude of AC output voltage, amplitude of amplitude of AC output voltage. हाँ बोलिए.
मेरी तरफ से तो वीडियो लैग हो रहा है.
बाकी लोगों का कैसा आ रहा है वीडियो?
यस सर, वीडियो लैग हो रहा है.
लैग हो रहा है.
लैग हो रहा है और ब्लर भी हो रहा है.
ओके जस्ट गिव मी 1 मिनट. ब्लर भी हो रहा है क्या?
यस सर.
ब्लर तो नहीं होना चाहिए. अभी कैसा है?
क्लियर है.
Okay. Now calculate. Now when I want to calculate DC current, okay, then first step is what?
ईटा कितना दिया हुआ है?
Eta 1 दे रखा है. Okay. So find the DC current. Okay. So DC current के लिए what I will do? I'll make short circuit source. Okay. So for DC analysis, okay, short circuit AC source. Okay. So I'll make AC source short circuit. Okay. Now this is a 12.7 battery. Okay. Now when current will flow, these all diode will become, we can replace by batteries. Okay. This become 0.7, 0.7 and 0.7. Okay. So now it's easy to calculate IT. So IT will be what? IT will be 12.7. Okay. And 4 into 0.7, that is 2.8 divided by 9,900 ohms. Okay. This will give how much? If two removed, so how much volts? 9.9 volts.
Yes sir.
So this become 1. So this become how much? 10 raised to power 3, that is 1 milliampere ID. Okay. So now you know ID value. Okay, you can find easily what is next. Next is when you are using AC source. Okay, we are input equal to VP sine omega t. Okay, VP is given 100 millivolt. So you have to short circuit this one. Okay, and each diode will be replaced by a resistance, and the resistance value will be RD eta is given 1, so VT you can take 25 or 26. Okay, they are given 25, so you take 25 millivolts into 1 milliampere. Okay, cancel, so you're getting 25 ohm. So now you have 4 diodes, so you have 4 resistance of 25 ohms. 25 ohm, 25 ohm, 25 ohm, 25 ohm. Okay, now you're asking amplitude. Okay, amplitude के लिए just we need to take BP. Okay, so if I take V output, so V output will be simply 9,900, so that will be 10,000. Okay, and you have VP sine omega t upon total resistance is 10,000 into, you have to find resistance across 100 ohm. So this becomes Vp sine omega t. Okay, this becomes your 10 raised to power 2, and this is your 100 millivolts sine omega t, and this is your again 100 cancel. This become 1 sine omega t. Okay, so your maximum amplitude will be how much? This is
सर
millivolts. Okay, हाँ, so maximum, हाँ
सर
बोलिए.
प्लीज ये बताइए, यहाँ हमने आरडी के कैलकुलेशन में 25 इंटू 10⁻³ कैसे लिया?
25 millivolt है ना. So output peak they are asking, output peak that will be your 1 millivolt. हाँ आप बोलिए, आपका तो RD तो 25 millivolt है ना, and we add eta VT, formula क्या है? Eta VT upon ID.
हाँ
VT is 25 millivolt, this is milliampere. Okay, so this is your answer. This question came in GATE EC. Okay,
10⁻⁴ कैसे लिया?
10⁻⁴ कौन सा वाला? ये वाला ना, 100 प्लस 9,900 कितना होगा?
ओके सर,
Series ना, you are voltage across this one. This is your V naught na. 9,000 plus 100 ohm. This become your 10 raised to power 4, 10 raised to power 2. Cancel, you have 10 raised to power 2. EP is 100 millivolt given. Okay, so you have this one. So amplitude is your 1 millivolt. Now one question came in your GATE 2012 physics. GATE 2012. Okay, so they have given you a battery of 24 volt. Okay, then they have given you diode. Okay, and here is one more resistance. This is 12 kilo ohm, 6 kilo ohm. This is 3.3 kilo ohm. Okay, so they are asking calculate the current passing through the diode. Okay, current passing through the diode. They're asking this current ID. Okay, so and this diode is they given, diode is ideal. Diode requires 0.7 volt. Diode requires 0.7 volt. Okay,
मतलब सिलिकॉन
सिलिकॉन है, मान लो सिलिकॉन है. Okay, now you have to calculate ID. So when diode is silicon, you can make it open and you can see easily that voltage across this diode, this is silicon, is more than your 0.7 volt easily, because it's a 20 volt battery. Okay, so I can assume this is conducting. This is conducting. This means you can replace it by battery of 0.7 volt. Okay, now I want current. How much current is flowing in this circuit? Okay, so let's say total current is I flowing in the circuit. Okay, out of ID going here, so here current is I minus ID. Okay, so I have two loops now. I can do mesh analysis. Okay, so two loops are means, okay, diode is given plus minus. Okay, this is plus minus. Okay, so now you can write the loop equations. So this is minus 24, okay, plus I into 12 kilo ohm. Okay, and here current is I minus ID. So say I minus ID into 6 kilo ohm. Okay, equals to 0. This is the first equation. If you solve this one, okay, so solving, how, what you'll get if you solve this one? So you got 24 I into 12, 12,000. Okay, so and you have this 6 here. So solve this one. This is one equation number 1, and second equation I can write here. Okay, so this voltage is equal to this voltage. Okay, so what I can write, I minus ID, okay, into 6 kilo ohm equals to this voltage, 0 0.7 plus 3.3 kilo ohm into ID. Okay, solve these two equations and tell me what the answer is coming. I'm writing the options. Options are 0.5 milliampere, 1 milliampere, 1.5 milliampere, 2 milliampere. Okay, so options are 0.5 milliampere, 1 milliampere, 1.5 milliampere, and D is 2.0 milliampere. Can you write? Can you solve? So you have here minus 24. So 6 into 10 raised to power 3 I. Okay, and I12 is also coming here. So 6 plus 12, 18. 18 into 10 3 minus 6 into 10 raised to power 3 ID equals to 24. And if you solve it further, what will come? So this will come your 18. Okay, so you divide by 6, so 3I minus 2ID. Okay, you're dividing by 6, so you come 4 and 10 raised to power minus 3. 24 4 into 10 raised to power minus 3. Similarly, you can solve this one. Okay, here you have 6I, 6 into 10 raised to power 3I minus 6 into 10 raised to power 3 ID. Okay, and this is 3.3 minus is minus 3.3 into 10 raised to power 3 ID. This is 0.7. Okay, so how much become? This becomes 6 into 10 raised to power 3 I, and this 6 2.7 minus 2.7 10 raised to power 3 ID equals to 0.7. Okay, and then you solve it further. You divide by 6 or 3. If you divide 3, it's become 96. If you divide by 3, okay, so you got divide 3, so it become 2i minus 2.7, 0.9 id. Okay, now 0.7 into 10 to the power minus 3 divided by 3. Solve these two
Sir,
equations.
option B.
Option B is 1 milliampere. Option B is 1 milliampere. ओके, बाकी लोग का आ रहा है?
Yes, sir.
ओके, आ जाएगा. GATE 2020. Okay, simple question they asked. They are given you 10.1 volt. Okay, and they have given a 1 kilo ohm resistance here. Okay, and they gave you 3 diodes, silicon diode. Okay, grounded. So you're asking the current I in milliampere through the resistors. How much current is flowing through the resistance? So this is 0.7, 0.7, 0.7. Okay, so current will be what? Current will be I 10.1 minus 2.1, that is 3 into 0.7 divided by 1 kilo ohm. Okay, so that is 10.1 minus 2.1 upon 10 raised to power 3. So this become how much? 8 to 10 raised to power 3, that is 8 milliampere, and this is our answer. Okay, any question? Now the next question, okay, is from net. Okay, this is PI net JRF, net JRF 2016. Okay, so they gave you the dependence of current I on the voltage. Okay, so they gave you a diode current. Okay, a dependence of current I on the voltage V of certain device. Some device is there. Okay, is given by 1 minus V upon V naught upon square. Okay, where I0 and V0 are constant. I0 and V0 are constants given. Okay, okay, so this says now you are varying this V and you are measuring the current I. Okay, so I want to measure this parameter I naught and V naught. Okay, from the graph. So how to estimate I naught, okay, and V naught from the graph. If we vary V, I will change. Okay, so they give you some plot. So that plot, how can I get the value of V naught and I naught? Okay, and for that they have given you some options. Okay, like that he says how to calculate V naught and I naught. So from the graph slope or intercept, or from how can we calculate V naught and I naught? Tell me, how can we calculate V naught and I naught?
Sir, graph is given or graph we have to plot?
The relation is given. Okay, you find if you plot, you find out the plot the graph and tell me how can you calculate these two things. So you can easily plot this graph, na? If I want to plot this graph, okay, so let us say I want make it, say this is my root I, this is root I naught. Okay, for simplification I'm plotting like this. You can take log also. Okay, but I'm plotting this like this. So now how can I plot? You see, this is root I. Okay, this is root I, and if I plot this one, this is I naught.
ऑप्शंस
root I
कैसे
naught.
हैं इसमें?
हाँ?
ऑप्शंस कैसे हैं?
ऑप्शन मतलब स्लोप से निकल रहा है, इंटरसेप्ट से निकल रहा है, कैसे निकालोगे आप वी नॉट और आई नॉट ग्राफ से?
मतलब सर ग्राफ वैसे नहीं बने हैं डिजाइन में, मतलब
you make the relation, plot the graph. पहले ग्राफ प्लॉट करो, बताओ ग्राफ का स्लोप क्या है. So here you can see this is a y plus, say if I say this is y, okay, then this is my c and this is my mx. Okay, if I take v equal to x, then my m slope is what? My slope is minus slope is minus I naught upon, this is my slope. Okay, and if I plot this graph, okay, this is y, that is root I, y equals to root I. If I plot, okay, and this is my v, so at y axis v naught 0, so this, so at y intercept will be my I naught, it will cut here, it will cut here somewhere here, and this will give me what? Under root I naught. Okay, and you can put here at v, here the slope of the graph is of what? At y axis, at x axis what? Your y, I is 0. Okay, I is 0 means where it will cut. If you make 0, if you make it 0, okay, so this is cancelled, so your v will be equals to v naught, so somewhere it will cut it v naught, isn't it? So that's it, that is x intercept. Please check it whether it's correct or not. Okay, so I want v naught.
Sir, y intercept, no, it will be.
Huh?
It will be a y.
So it says the option, the what option they given, this is not given, and this x intercept option they are not given. So suppose you want to find v naught, okay, so they are given the option slope. You take the ratio of the minus intercept of negative of the ratio of the y intercept. So y intercept is your how much? Root I naught upon the slope. Slope is also minus, and slope is what? Minus I naught upon v naught. So minus cancel. This will become v naught. Okay. So the ratio of, you can find out the v naught with the ratio of the negative ratio. The negative ratio of, okay, y intercept to the slope of the graph, okay, and I naught, you can find the y from y intercept. So they given option v naught you can calculate by this ratio, and I naught you can calculate by the y intercept. The option D is given, the negative of the ratio of the y intercept and the slope and the y intercept of the IV graph. Okay, so this is your IV graph under, this is what
Sir,
your
is on the
बोलिए.
basis of slope we have find out, or is it the formula?
स्लोप तो निकाला ना, स्लोप तो दे रखा है ना, इक्वेशन लिखा था ना मैंने, इक्वेशन से निकाला स्लोप मैंने, इक्वेशन से. Now you can find out v naught by x intercept, but that is not given in the option. So other way is what? Obviously you know the slope, you know the x intercept. If you take the ratio, you know the y intercept, you know the slope. If you take the ratio of the slope to y intercept, obviously you get x intercept. Okay. So this is a, so v naught you can find by this ratio, and I naught they asked, I naught you can find from the y intercept. Any doubt?
Sir, still I'm not
Sir, y
getting
intercept,
that should
x
first.
intercept,
तो ऑप्शन में नहीं है ना, ऑप्शन में they have not given they are not talking about x intercept. If they are x intercept, directly you can find I naught from y intercept, and v naught you can find from x intercept. Okay.
sir, I
हाँ,
zero इक्वेशन में से ही नहीं y वो put करके हम निकाल सकते x intercept.
so they are asking question, the parameter v naught and under root I naught can be graphically determined as, okay, how, if we have a plot of the graph equation, how can we calculate these two parameters? So I naught is y intercept, and the ratio of negative y intercept to the slope is your v naught. Clear? You have your booklet. You check this page number 149. This is the first question, net JRF 2016. Okay, you check it. Any doubt? So there is no other way to calculate v naught. What the options they are given? This is the slope the slope and the y intercept of the IV square graph. Okay, so IV square graph, if you plot, okay, slope will not give you this value. Slope will not give you v naught, because slope is this, and if you when you plot IV square, then also slope will not be equal to v naught. Okay, the second option, then negative of the ratio of the y intercept and the slope. Okay, negative of the ratio of the y intercept and the slope, and D option is the same. Of IV square graph, that will also not give you. Okay, so when you plot under root IV plot, okay, then only this option is correct. You check the options, and if you have in doubt, please come back to me. And then given you December 2016, okay, again they given you the IV characteristics of a device, okay, can be written as IS exponential, okay, AB upon T minus 1, okay, where T is the temperature and A and IS are the constant independent of T. So which of the following plot is correct for fixed applied voltage? Okay, if voltage is fixed, you're keeping fixed voltage and increasing you're changing the temperature. Okay, so which of the following graph is correct? Log I versus AV by T. They are assuming AV by T is X, and they have given you graph like this. Option A. Option B is log I. Okay, and somewhere here, starting from 0 and is becoming constant, and is becoming constant. Okay, and option C is given. Okay, and this is your 0 line. So here negative values also are negative values also there. Okay, -1, -2, -3. This is log I, and the third graph is they given. Third is also log 1. Okay, and this is getting at 1. Third option is, again they give you 0 line. Okay, this time they are increasing, but they are going above 1. This is log I versus AB upon T. And the option D is they given this one. Okay, 0 line, and these are negative values, and these are increasing, and like this. This is your log I versus AB by T. Okay, tell me which of the following graph is correct. These all are negative values.
डी
minus
वाला
minus 3. Okay, why D?
सर यदि हम ए बी बाय टी को x ले लेंगे
हाँ,
तो उस x को उधर ट्रांसपोज करेंगे तो एक्सपोनेंशियल फंक्शन लॉग फंक्शन में चेंज हो जाएगा
yes.
और सर लॉग
Okay,
फंक्शन फिर x के साथ वेरी करेगा जब
so
टेम्परेचर वेरी होगा तो
very good. So but what we can do, if you assume this is by x, because you're plotting like this, na x. So if I take I equal to is, if I take this is a e power x minus 1. Okay, so as x is increasing, of course t is decreasing. Okay, a v is constant, a is going to a v by t is increasing, that is t is decreasing. In that case, what will become, this function you can write what, is e power ex. Okay, now if you take log, you send here, you take log I upon is equals to x log e power x, so this become 1. So you got log of I. Okay, and you got here x, and you can send log is, which is constant here. Okay, so that means your log I will be x plus some constant. Okay, so this is what, at higher value of x, this should be a straight line. Okay, higher value of x, this should be a straight line. So this is straight, they all are giving constant. So option D, after a certain value, this is becoming linear. So the option D is correct. So question clear है कि नहीं है? See, all other options are not correct. They are getting saturated. Okay, and this should vary. Log I should be proportional to x. Okay, for higher value of x, your log I should be proportional to x. So this is the option correct. Okay, now this one simple questions we have already done in the class. Okay, that also came in JAM also. So you need to tell me what is the answer. I will not solve this one. IIT-JAM. Okay, so they have given you a diode. Okay, they have given you 10 volt. Okay, D1, D2, and they have given you, this is your 100 kilo ohm resistance. Okay, and they tell you this is the graph of I versus V for a diode. That means you need to take a constant voltage drop model. Okay, and they say the diode D1 and D2 with threshold voltage of, this is 0.7 and this is a 0.3. Okay, the threshold voltage given for these two diodes, and they are asking, okay, find the current through the resistor R. Find the current through the resistor R. Calculate how much is coming.
Can you repeat the question, please?
You need to
सर
find
रेजिस्टर आर का है मतलब 100 किलो ओम के अक्रॉस निकालना है क्या?
you need to find current I in the circuit. Diodes, two diodes are connected. Both diodes cutoff voltage given 0.7 and 0.3, and they are asking how much current is flowing in the resistance 100 kilo ohm. This question actually we have done.
Sir, 0.997.
कितना?
97 micro.
Microampere, 97 microampere ना?
Yes, sir.
So you need, you know, when this is 0.3, so obviously this will conduct. This will conduct and this will get open, because this is a, we already discussed this question already. Okay, because this is a higher voltage, so lower voltage it will conduct. So once it is 0.3, it cannot go to 0.7. Okay, so obviously now you want current I. Okay, that will be your 10 minus 0.3 upon 100 kilo ohm. Okay,
So 0.9 micro ampere.
9.7. Okay, and 10 raised to power minus 5. If you divide, okay, so it's 97 into 10 raised to power minus 6. Okay, so this is 97 microampere. This is the answer. Okay, there's one more good question. So we have a diode at room temperature. Okay, for that they have given KT equals to 0.025 electron volt. Okay, with a current of 1 microampere. Okay, has a forward bias voltage, this one and this one. Okay, so so basically they have given you a reverse saturation current value as 1 microampere. Okay, and then they are applying forward voltage Vf equals to 0.4 volt, and then they are applying Vf equals to 0.5 volt. Okay, so they're asking the value of diode current. What is the value of diode current? Just give me 1 minute. Let me check the question exactly what they're asking. So this is, you have been given. Okay, so a diode with a current of 1 has forward bias voltage. Okay, so this says when the voltage is 0.4, okay, 0.4, that time your forward current IF is, okay, IF is 1 microampere. Okay, when the voltage is this much, the current is this much. So when the voltage is 0.5 volt, what is the value of current? Say IF1, IF2. Say IF1, IF2. Calculate.
Eta 1 ही मानना है. Eta 1 ही मानना है.
Double.
Eta.
Eta you can take 1. If eta is not given in the question, you should always take 1. Okay, so I hope you have noted down the parameters. Okay, now what exactly they're asking? You're asking ratio of I2 upon I1. Now I1 they have already given you 1 microampere. So you know the current from diode is equal to IS exponential, okay, QB upon QB upon KT, okay. So obviously they have given the value of VT to you, okay, 25 millivolts, okay, minus 1, and again your IS exponential V upon first is V1, first is second case is V2, say V1 upon Vt minus 1, okay. So you want I2, I2 will be I1, okay, into this V2 is exponential, V2 is your how much? 0.5, 0.5, okay, that means 500 millivolts, and this is your 25 millivolts. One we can neglect because this ratio is high, so I can neglect this one, and here I have exponential, okay, this is 400 millivolt upon 25 millivolts. So what I get now, I1 is 1 microampere, okay, exponential, this become millivolt cancel, this become 20, and this become how much? 1 16, okay. So you have exponential 20 minus 16, okay. So you have 1 microampere e power 20 is
वन
your,
निगलेक्ट है
हाँ हाँ 1 लेफ्ट कर दो
वन
क्योंकि ये रेशियो बहुत ज्यादा है ना. This 20 power 20 is coming, so this one is negligible, okay. So this should be the answer. E power 4 10 raised to power minus 6. Tell me how
Yes,
much
sir.
it come?
54.5
54.5.
microampere.
Okay. So this should come 54.5 microampere. बाकी लोग भी चेक करो कितना आ रहा है. सबका आ रहा है क्या?
Yes, sir.
So the next question is, let I0, they given I0 be the saturation current, okay. So I0 given saturation current, okay. Eta is given ideality factor, okay. Vf is given forward bias voltage, forward bias voltage, and Vr is given reverse bias voltage, reverse bias voltage, okay. They are asking what is the ratio of R reverse bias to R forward bias for the diode, okay. And they have given you options: A Vr upon Vf exponential QVF upon eta kBt. B is given Vr upon Vf upon Vr exponential QVF eta kBt. C option is Vr upon Vf is equals to exponential minus QVF upon eta kBT. Okay, and the D option is what? VF of VR. Okay, exponential minus QVF eta kBT. The question is simple. You are applying one time forward bias, other time reverse bias. Okay, so both the case you need to calculate. Okay, what is the ratio of? So let me further clarify what is the question. Okay, so you have diode in forward bias. You are applying some voltage. Okay, say VF this time, and you get some current IF. So obviously your ratio will be what? VF upon IF, isn't it? Okay, and second
option
case,
A.
let me check. Okay, and the second case, they are saying you have diode in reverse bias. Okay, diode in reverse bias, that means negative is there, positive is there. Okay, so this time current will flow like this, current will flow like this, and this time you calculate again your RR. So this is plus minus. Okay, so obviously
current, saturation current लेगा.
saturation. So this time you want to find VR upon IR. Okay, and they ask ratio of RR for VR. Okay, so if you want to find the ratio of RR upon RF, okay, तो क्या आएगा? VR upon IR, okay, into IF upon VF. So IF is what? IF is simply your I saturation exponential, okay, QV eta kBT minus 1. Okay, so this is a forward bias, so you can neglect 1. So this is your forward current, and reverse current IR is simply when you put minus here, it comes out minus I naught. Okay, so but you take a resistance, the resistance the ratio. Okay, so that will also in negative direction, so you get IR, you can take IR equals to I naught. Okay, you take minus I naught, I have no issue. Okay, so then VR will be also minus. Okay, so minus 1 is finally it will cancel, so you will get what? VR upon IR is your I naught. Okay, you have VF, and this IF is what? Exponential QVF upon and eta kBT, and I naught will be cancelled. Okay, so what you're getting? VR by VF and positive. You're getting C, na? How it come 1? A. This A. This option A is correct. Option A is correct. Please check it whether you're getting option A or what you're getting. Let me check also.
Sir, I'm getting C.
No, this is actually option A. A,
No,
B,
sir, C.
C, minus you're getting.
Yes, sir.
Okay, give me one question. Question 3 of
माइनस कैसे आएगा? माइनस तो फॉर्मूला में नहीं है सर.
नहीं, प्लस आएगा. Plus is coming. VR upon VF and plus is coming.
Sir, option A is coming.
Yeah,
Minus cancel. VR and IR both are negative now.
Yeah.
Cancel.
So A option is coming. Okay. C won't come, no, because option you don't have minus here. Forward current. Okay, forward current is up, na. R, they ask R, they don't ask RF upon RR. They ask RR upon RF. Okay. check it once. Okay, this question also came in exam. Just give me 1 minute. Okay. So they given you a current source. Okay. That is open, and they have put one capacitor here. You see, and this is your, they are measuring V output. Okay. So this says with time, how the V output will vary. V output will vary with time t. They are given the options like this. B, they are given like this. Okay. C, they have given V output versus T, and option D, they are given V output versus time T. So which is the correct option? Which is the correct option? So you know the diode equation, diode current expression. Once you close this switch, what will happen? Your capacitor will start charging. Okay. So what will be the voltage? Initially it is uncharged. Initially uncharged means you have a zero voltage. Now you're charging. So what will happen? So initially
Sir,
you have,
D.
okay. So initially this is uncharged. Now you're allowing current I. So obviously the current will be now C. Okay. And C will be what? D final. Okay. Upon dVt. Isn't it?
Sir, it is constant current source, na?
Constant current source.
So diode equation,
Hmm?
how we can apply diode equation?
Okay. So initial diode is zero. The final voltage is V naught. Okay. So how can we say? Tell me what will come.
Sir, option D.
Just 1 minute. Option D is there, but I have one doubt. Let me clear.
डाउट तो मेरे को भी है इसलिए
Just 1 minute.
एक बात पूछनी थी
Yes. Okay. So DVDT. ठीक है. Okay. So initially the capacitor is uncharged. Okay. So now I will write dV by dt equals to I by C. Okay. Now once I write this one, initially capacitor is uncharged. So now if I calculate V naught with time, okay, so this will come, I is constant, C is constant. So I will come obviously 0 to T dt. Okay. So this will come I by C T V naught. Okay. Plus some constant will come, but at t is equal to 0, you see is t is equal to 0, V naught is 0. So that constant will go. Okay. So you get this one only I by CT. Okay. That means your voltage V output is proportional to time. Okay. Proportional to time, that means it will vary like this. Okay. And once after some time, it becomes, this voltage become constant. So this is option D.
सर
हाँ
इसमें जो ऑप्शन ए दिया था,
हाँ,
क्या एक पर्टिकुलर टाइम तक वो भी हो सकता है?
नहीं देखो, पर्टिकुलरली एक तो होता है जब साथ में रेजिस्टेंस होता है, ओके, साथ में रेजिस्टेंस होता है, देन यू हैव एक्सपोनेंशियल, यू नो व्हाट इज द चार्जिंग इक्वेशन, दैट इज 1 माइनस I जीरो 1 माइनस ई पावर माइनस एक्स, ओके। सो हियर यहाँ पे रेजिस्टेंस नहीं है ना, यू डोंट हैव रेजिस्टेंस हियर। अगर रेजिस्टेंस होता then that will be like this, something like this, okay, but there is no resistance in the picture, only you have capacitor, so this you can directly write, okay, this will be like this. Varna you have to write the charging equation for RC capacitor, when R was there, then you have to simply write the RC equation of charging, but here no resistance, so you directly getting V0 is proportional to T, okay, and after some it will become constant. If it is R is there, then picture is different.
So capacitor is charged, that's why voltage will remain constant na after time. Capacitor gets charged and that's why.
this is a fixed current, so obviously that voltage cannot go infinite, na? If fixed current is fixed current, after some time it will become constant. Constant current is there means there is a constant voltage source in the circuit. Okay. Always you can replace this constant current source by a voltage source. So that is a fixed voltage cannot go beyond this one, PT. It cannot be indefinitely increasing. Okay. So now please solve other problems also. Okay, which is given in the material. And if you doubt, please ask. Okay. So now your diode is finished. Next class onwards, we'll start your transistor. Okay. So I like to stop here. If you have doubt, please ask.
थैंक यू सर।
Thank you, sir.